This week, we are going to discuss exponential growth due to how COVID-19 is affecting our daily lives. The idea behind exponential growth is something always growing in relation to its current value. For example, something always doubling or tripling. If the something we are talking about is money, then exponential growth is amazing. Who doesn't want to see their bank account increase in value quickly? But in the case of the spread of COVID-19, exponential growth is bad. The term exponential isn't related to the size of the number, but how quickly the number changes. The rate of new infections depends on how many people are contagious, so that number is going to increase rapidly. The good news is at some point that exponential growth is going to level off. It's just hard to know when you're in the middle of exponential growth to know when that will occur. In the case of COVID-19, that leveling off won't become apparent until after all the safety precautions we as a country have put into place have had time to take effect. To better explain the connection between exponential growth and COVID-19, I'm going to use excerpts from another YouTube video posted by Minute Physics called How to Tell If We're Beating COVID-19.
That epidemics tend to grow exponentially at first, and also that exponential growth is really hard for our human brains to understand because of just how crazily fast it is. Note that the tick marks grow by multiples of 10, so 10, 100, 1,000, rather than 10, 20, 30. This scales up small numbers and scales down large numbers, making the growth equally apparent on all scales, and lets us compare the growth in countries with very different numbers of cases. The defining feature of exponential growth is that the number of new cases is proportional to the number of existing cases, which means that if you plot new cases versus total cases, exponential growth appears as a straight line. So these are what we plotted on our graph. The number of new cases, aka the growth rate, is on the y-axis, and the cumulative number of cases is on the x-axis, both on logarithmic scales. This gives us a beautiful, horrible graph that shows where all countries are in their COVID-19 journeys. It makes it obvious that the disease is spreading in the same manner everywhere. We're all headed on the same trajectory, just shifted in time. And it makes it obvious where public health measures like testing, isolation, physical distancing, and contact tracing have started to beat back the disease, and where they either aren't working or haven't had time to show up in the data. In nearly every country so far, the number of cases grows at basically the same rate, until it doesn't. And that's what I feel like is missing from so much COVID-19 coverage, a sense of whether or not we can see the light at the end of the tunnel. Are we still on the rocket ship of contagion, like the US? Or have we managed to hit the emergency eject button, like China? 10,000 looks really close to 1,000 on a log scale. This kind of distortion might allow people to take COVID-19 less seriously. Also, the log scale on the x-axis makes it harder to see a resurgence of new infections after a significant downturn. A plot with a linear x-axis is better for that. Unlike most other COVID-19 graphs you've probably seen, time isn't on the x-axis, which might be confusing. Instead, time is shown through an animation. Another important caveat is that this graph, and basically every other COVID-19 graph you've seen, isn't actually showing the true number of cases, just the number of detected cases. The true number of cases is unknown, but certainly much higher than the number detected. In reality, COVID-19 cases spread at a slower rate than what this data implies. It's kind of a subtle idea, but this data reflects not just increases in case numbers, but also increases in the number of tests performed. And since we're ramping up tests, it makes it look like the cases are growing faster than they actually are, but they're still growing. The data we're using is incomplete, as it relies on daily reports from overburdened healthcare systems around the world. Also, different countries have dramatic differences in the resources that are available and dedicated for testing. Finally, the trends in this plot are delayed a few days, since we're plotting the average growth rate over the last week. There's just too much variability in the data to plot daily growth rates. This is actually kind of a good thing. It means it's a pessimistic graph. It doesn't get too excited too soon, and so a downward trend on the graph is much more likely to be a real downward trend. And a real downward trend is what we want for all countries. A lot of daily news just reports recent data points. Yet to understand where we're headed, it's not enough to know just where we are today. We need to be talking about trends. How many new cases are there today relative to the number of new cases yesterday or last week? Charting the rate of change empowers us all to more clearly see what the future holds.
Okay, so here's your bonus assignment for the week. I want you to go to the website that's at the bottom of the screen, and I want you to play around with the graph that was shown in the video. It's going to initially be on the logarithmic scale. You can change it to a linear scale and just see how that affects things. You can choose some of the countries, all of the countries. Look at their exponential growth, because remember, it's going to look like it's on the same trajectory as shown in the video, but think about what it means to be exponentially growing. Things are either going to be increasing faster or slower than other countries. Look at those things in terms of the numbers. In the comments, tell me, what did you learn from comparing the different countries from one another, the different scales? Just play around with it, explore, and just learn a little bit more about what is going on in the world today. And I'll see you next week.